For this problem, we'll once again write our general formula for these exponential decay functions. We have f of t is equal to a, our starting value, multiplied by our base raised to the t power. So essentially, we just need to figure out what a and b are. And jumping into this problem, at the moment, a certain medicine is injected. Its concentration in the bloodstream is 120 milligrams per liter. From that moment forward, the medicine's concentration drops by 30% each hour. Write a function that gives the medicine's concentration in milligrams per liter, C of t hours after the medicine was injected. So when dealing with word problems, remember it's good advice to just rewrite what the variables actually mean here. So we have C of t and we have t. We know t is hours, so that's time. And again, our unit is hours. And then C of t, that is the concentration of the medicine, or we can say the medicine's concentration. And we also know the units for that. That's going to be in milligrams per liter. So we can write that as mg divided by L. And once we know what our variables represent, we can now go back and look at the information given. And what we can notice is that the moment the medicine is injected, the concentration is 120 milligrams per liter. So we can say when t is equal to 0, that's the moment it was injected. The concentration, or you can say C of 0, is 120 milligrams per liter. And notice writing down the units will help you identify whether you're given the function value or maybe you're given the time value. So we were told milligrams per liter, which matches up with what our function should be written in. So we know our starting value. This is just a in our formula. And now we just need to figure out the base. And we're told that the medicine's concentration drops 30% each hour. So our base in this case, well, we start with the current amount of the medicine. So we originally have 100%, and then we're subtracting 30% every hour. And rewriting these as decimals, we know 100%, that's just 1, and 30%, or 30 over 100, is 0.3. And 1 minus 0.3 is just 0.7. So from 1 hour to the next, the medicine's concentration is going to multiply by this 0.7. So that's our base. We know our starting value. And so we can rewrite our function, C of t, as that starting value, which is 120, multiplied by that base, 0.7 to the t power. And to check this, we're just going to make a quick table. So we want to make sure that this formula works, but to test the formula, we need to come up with some values by just thinking this through. So we have t and C of t. And when t is 0, we know there's 120 milligrams per liter. And after 1 hour, we know it's going to drop by 30%. Well, we can find 30% of that. That's 36 milligrams per liter. And we can subtract that. So that would bring us to 84. And going to the next hour. So hour number 2, we're again going to drop it by 30%. And if we take 30% of this, so 10% would be 8.4. We multiply that 3 times, and that gives us 24 plus 1.2, which is 25.2. And so we need to take 84 and subtract 25.2 from that. And let me just make a little bit of room here. And that will give us 58.8. But what you can notice is that when you're going from 1 hour to the next, that you're just multiplying by 0.7. You can double check that with your calculator. But let's now check our formula. So if we plug in 2 to our formula, we should get 58.8. So that's 120 multiplied by 0.7 squared, which would be 0.49. And if you check with your calculator, 120 multiplied by 0.49 does give you this 58.8. And again, the units are milligrams per liter. So we got back what we expected when we did this by hand with a table. So we can feel confident that this formula is correct. So C of t is equal to 120 multiplied by 0.7, all raised to the t power.